Hey guys, I want to go ahead and talk about a couple of problems about exponential growth and decay. So let's just go ahead and do these two examples. It says the world population in 2000 was 6.08 billion. Now, when you talk about exponential growth and decay, you got to kind of recognize it. Anytime you see that the growth rate is a percentage, that's a good indication that it's exponential growth and decay. So it's you have to recognize what the question is telling you. So you see here the population is 6 billion. The rate of increase was what? 1.26%. So that right there already tells me that I'm going to be using exponential growth, which is y equals ab to the power of x. This guy, your a, that's what your starting value is. Okay? In this case, it's 6.08 billion. The b is your growth. How is it growing? Well, it's growing this way. Okay? Now, the only thing when it's growing, it says the annual rate of increase, so it's increasing. So what you're going to do is you're going to take 100%, you're going to add 1.26%, and that's going to give you 101.26%. But remember, you got to change this guy into a decimal, so that's going to become 1.0126. Okay, so now that I have that, actually that's part A, the growth factor. What is the growth factor? The growth factor is 1.0126. Okay. Now this question is in different parts, and it kind of leads to how to complete the problem in the end. But that's part A. Okay, so you take your 100%, and because it's increasing, you're going to add the rate of growth, and you're going to end up with 1.0126. The part B, it says write a function that models the world population. Well, the function is represented by this guy. So we're going to write y equals a is your starting value, 6.08. Our b is our growth factor, which is 1.0126. Okay, to the power of whatever that is, x. Because it just tells you write a function to model. That's all it is. Now remember, because it's a real life situation, we're not using y and x. X is going to be represented by time. Okay, 6.08, 1.0126 to the power of t. And y represents, well, what we're talking about. In this case, is the population. So the population is going to equal to this value. And your professor might even tell you to write it as a function of time. So the population in terms of time with respect to time is given by this. So now we can go ahead and do part C, which is find the population into 2010. Well, how many years is that? Well, remember, in 2000, it was 6.08. So from 2000 to 2010, well, that's approximately 10 years. So now all you got to do is plug in 10 into your t right here, and that's going to give you the values. So the population in terms of time in the 10th year, 1.0126 to the power of 10. You're going to have to go ahead and plug it into the calculator, but you should get approximately 6.891 billion people. All right, guys? And that's how you do that one. Whoops, there it is. And that's how you would get that one. Let's go ahead and do one more. This one, it says a computer is valued at $6,500. It depreciates. And you see this? That means it goes down in value. So what do? Well, we're talking about the same format here, y equals ab to the x, because I noticed that it's a percent increase per year. Well, I'm going to take my 100%, but this time, instead of adding it, I'm going to subtract it. Why subtract it? Well, because it's depreciating. It's going down in value. So when I do that, you're going to get, what is that, 0.7%? 9 is that 86.7%? Looks like it. 9, yeah. Okay. So now this has to be turned into a decimal, which becomes 0.867. Remember, you have to move it 2 spaces to the left. All right. So now we can go ahead and write the function that models this situation. So we're going to write y equals a is my starting value, which is 6,500. Our growth is 0.867, which is actually, it's decaying because it's going down in value, and it's to the power of x. But remember, because this is a real life situation, we're not going to use y and x. We're going to say the y is actually the computer value. So I'm going to just put c. the computer value in terms of time, okay, because we're talking about year. So we're talking about 6,500 to times 0.867 to the power of t. Okay, so the value of the computer in terms of time is 6,500 0.867 to the power of t. Well, where did I get 867? Remember, 100% take away 14.3. Why did I subtract? Because it's depreciating, and you change the percent into a decimal. So now, after 3 years, I can go ahead and solve it. So the computer, the value of the computer in 3 years, okay, all I got to do is go ahead and plug it into my calculator. And sorry if I'm going kind of fast. And it should give you approximately $4,091. All right, guys. So that's how you do exponential growth and decay word problems. All right, guys. See you guys next time.